Okay, now we are going to move from the compound angle to the double angle formula now. Um, Now you look at this, you have cos 2x, and then you have sine 2 theta, and then you will be having tan 2 theta. So if I try this fifth question here, so in this fifth question, we have 3 cos 2x, okay? Now, there is something bad over here in this fifth question. We are not given that what is the limit for x over. Oh, he's just asking for sine x. Okay, so I thought we had to find some angle. So we only have to find the value of sine x. Okay, good. So now, so this is going to be 3 cos 2x and plus 17 sine x, that is equal to 8. Now this cos 2x formula is very important, okay? Now this starts from, like, this is cos alpha plus beta, that is cos alpha cos beta, and then you have minus sine alpha, and then you have sine beta. So now you change this with the, like if both of them are alpha, or maybe both of alpha and beta are x, so then you have the formula cos 2x, okay? So that becomes cos x minus sine x. So that means your cos 2x is going to be cos square x and then minus sine square x, okay? Then this cos 2x can be written only in terms of cos. So this will be 2 cos square x minus 1. And if you want to write this purely in terms of sine, so this will be 1 minus 2 sine square x. So this is a very, very important formula of this cos 2x. And this is used a lot in your A-level mathematics, in complex numbers, in vectors, in differential equations. You will see that in integration and differentiation. So right now we need this cos 2x version that is going to be in terms of sine, okay? The problem is that whenever you are solving a trigonometric equation, the whole equation should have the same angle. It should not be like this. Okay, this one has an angle of, you see, this angle is 2x over here, and this angle is x. So this should be transformed into an equation which has the same angle over here, okay? And then when you try to make the angle same, then you should try to have the same terms, like the same trigonometrical ratios. Either you have cos or the sine or the tan. So I'll be using this formula from here, because this lets us change the cos 2x into an angle x with only the in terms of the sine, okay? So I'll change this, I'll pick this from here. This is going to be 3 into 1 minus 2 sine square x, and then plus 17 sine x, and that is equal to 8, okay? And now we have this 3 minus 6 sine square x plus 17 sine x minus 8 equal to 0. So we can write it as 6 sine square x minus 17 sine x plus 5. Now, after this is totally up to you. If you want to like change this, you want to use a substitution here. Some people, they find this, they are very comfortable saying that let this sine x is equal to alpha, let's say. Or maybe they can keep y or whatever you want to. So this is going to be 6 alpha square minus 17 alpha plus 5 equal to 0. So you can do that middle term breaking here, or you can use that quadratic formula. So this is 15 alpha minus 2 alpha plus 5, that is equal to 0. So you have um, 3 alpha common from here. This is going to be 2 alpha minus 5. This is minus into 2 alpha minus 5 equal to 0. So 2 alpha minus 5 into 3 alpha minus 1 equal to 0. So you have alpha equal to 1 over 3 or alpha equal to 5 by 2. So alpha is basically your sine x. So the exact values of sine x are going to be Sine x is going to be either 1 by 3 or this sine x is going to be 5 by 2. Okay, and like suppose if it was a question like sixth question, and then you had to see, okay, suppose you had to find the angle x, and the angle x was from 0 to 360, then you will have these two different cases. Okay, so you will say in this that this x is going to be in these two quadrants, and again you will get two values from here, these two quadrants. You will find sine inverse of 1 over 3. So you have two values from here and then two values from here. Altogether there will be four values of this x. Okay, so this way, if you look at the sixth question, so you will have to change this sine 2 theta. What is the sine 2 theta? Yes, sine 2 theta can be changed with the hmm, sine 2 theta is, you must learn all these identities by heart. That is 2 sine theta cos theta. And that is how your question will start. You will write in the beginning, you will change this with 2 sine theta cos theta. So this will become 4 sine theta cos theta. That is equal to cos theta. That is the sixth part A. Okay. Now you'll bring this cos theta to the left hand side. This time we will not be dividing both the sides by cos theta, because we can take this cos theta as common. Please see this. If this was just like this, 4 sine theta equal to cos theta, then you have to divide both the sides by cos theta so that you can have tan theta over here. But in this case, you see, this can be moved to the left hand side, and then we can take this cos theta as common. So this is going to be 4 sine theta cos theta minus cos theta, that is equal to 0. And then you take your cos theta as common. So this is 4 sine theta minus 1. And out of this, you now you have two equations. One is going to be cos theta equal to 0, and the other is going to be 4 sine theta minus 1 equal to 0. So now you have, you know that cos is 0 at 90 degrees and 270 degrees. And then this is your sine theta is 1 over 4. So please tell me what is sine inverse of 1 over 4. Tell me quickly, sine inverse of 1 over 4. Mhm.
Sir, 14.5.
This is 14.5. This is 14.5. So you have theta from here, 14.5 and 165.5. And finally, you can write all of them in an order. Okay, you can say that your theta is 14.5. This is 90. This is 165.5. And then this is going to be 270. So these are the four solutions of this. Okay. If you look at the B and the C parts, you should try them. They're exactly the same as the fifth question. You will end up with a quadratic equation in cos in this B. There will be a quadratic equation in sine in the part C. Okay. You try these questions, okay? And we can discuss them tomorrow, inshallah.